Alrighty, folks. Well, it looks like, what are we doing today? Oh, look, hey, we're graphing quadratics. So we have a fancy-dancy coordinate plane here. We're going to start with graphing the most basic quadratic using sort of the most basic way. Alright, so if I were to graph y equals x squared, okay, this squared is to the second power. That's what a quadratic is. Okay, it's when the highest exponent is 2. Okay, so I'm gonna graph this using a table. Okay, you can graph anything using a table of values. It may take a really long time, but gets the job done. Okay, and I'm just gonna put some numbers in here: -2, -1, 0, 1, and 2. You can pick whatever numbers you want. I happen to know that these are really good numbers to choose. These are good numbers to start out with in general, and then maybe you need to pick some other numbers which you discover along the way, but for our purposes, this is good stuff. So the idea is I plug this in for x, and then I do whatever's necessary to figure out what y is. In this case, I just need to square it, okay? So in this case, this is -2 squared. -2 times -2 is 4. This would be -1 squared. -1 times -1 is 1. 0 squared is 0, 1 squared is 1, 2 squared is 2. So each one of these is a coordinate point, and I'm going to graph each one of those. So -2, 4, -2, 4, right there. -1, 1, right there. 0, 0, 1, 1, 2, 4. So I just blew through those 5 points. And you can see this is not a straight line. Quadratics form what's called a parabola. Okay, and parabolas either look like this or look like this. They are symmetrical. This one's not quite as symmetrical as it could be, but they are symmetrical. They open either up or open down. I like to call this smiley and this one frowny. So I don't think there's any confusion on what that means then. Okay, so you can see that this one opens up. This one is a smiley. All right. Now, to know where to go next, we could throw in, say, a 3. If we do 3 squared, that would be 9. So it goes through right there. Okay? And if you think about -3 here, it would also go through +9. So it looks like that. Okay? So that, my friends, is the most basic quadratic, the most basic parabola. Okay? But of course things can get more complicated. We're going to be moving on and doing things more complicated. Okay, so, but it's going to retain this basic shape in general. Okay, so if we had something like y equals x squared plus 3. Okay, now if you think about it, if we use the same exact numbers here, this would be 4 for just x squared, but then we're going to add 3 to it. So 4 plus 3 is 7, right? Okay, -1 squared is 1 plus 3. Okay, this is going to be 4. 0 squared is 0 plus 3. This is going to be 3. 1 squared is 1. 1 plus 3 is 4. 2 squared is 4. 4 plus 3 is 7. So if we graph these, you can see it has almost the exact same shape. In fact, exactly the exact same shape. All right, this goes a little bit further out. But if you look at it, what is the difference between this and this, right? There's nothing here, and it starts here. There's a constant at the end of +3, and it starts here. So you see that this ends up, let me just change this here. Whoops, doop-a-doo. Okay. This means move up by 3. Okay? So that's all it does. It takes this graph and it moves it up. This means up 3. Okay? So in that respect, what do you think if we had y equals x squared minus 19.4. Okay, what would this do to just the basic x squared? This would make it do what? What do you think it would do? Go ahead and stop the video. Say out loud what you think it would do. Did you say that this makes it move down 19.4, down because of the negative, right? That's all it means, okay? So that's what adding a number at the back really does, okay? All right, now, moving on, what if we had something that looked like this? Y equals, oops, I don't know how to kill that. Doop-a-doo, want to kill it. Kill that. Here we go. Kill that. Okay. Y equals, let's go with x minus 2 quantity squared. Okay? Now, again, we start with our table. -2, -1, 0, 1, 2. So if I plug in -2 here, that's -2, -2 minus 2, and then squared. That's -4 squared, so that's -4 times -4 is 16. That's even off the chart. That's unfortunate. Okay, so let's see over here. We have -2 minus 1 quantity squared. That's -3 squared. Because -3 times -3 is 9. Okay, at least I can do that. Let's go with 0 minus 2 squared. That would be -2 times -2, 4. 1 minus 2 squared. 1 minus 2 is -1. -1 times -1 is 1. Let's see, 2 minus 2 squared. 2 minus 2 squared is 0. So, if I'm going to plot those, let's see here. Plot these points. No, that's not what I want to do. Okay, there we go. So, does that look like a parabola to you? I don't know. Looks like I'm not quite done. If I go like this, it's like, maybe I should keep going. 3. 3 minus 1 squared is 2 squared is, right? Oh, excuse me, 3 minus 2. What's a 2 there? 3 minus 2 squared. 3 minus 2 is 1. 1 squared is 1. If I plug in a 4 there. 4 minus 2 squared is 2 squared, that's 4. If I plug in a 5 there. 5 minus 2 squared, that's 3 squared, this is 9. So I plot those points, and it looks like a parabola. You see, it's like that. So that means that when it's in the parentheses before it's squared, this minus 2, okay, remember our original y equals x squared starts at the origin and goes up on either way. This starts right here on the x-axis at 2, 0. Okay. Can you guess what y equals x minus 4 quantity squared would do? Let's draw a new one here. This is a minus 2, and it starts at 2, 0. This should be a minus 4. Where do you think it would start here? It would start here at 4. And it would look just like the original y equals x squared, but this is moved 4 to the right. Okay? So, in other words, this means move right 2, right? This means move right 4. Okay, it's inside the parentheses before it's being squared. Okay, so that would mean that if we had something that looked like y equals x plus 5 squared, what would plus 5 mean? What would plus 5 mean? This means move which direction? Move left 5. Okay, move left 5. So in fact, If it's inside the parentheses and squared, it's the opposite of what you think. Plus means move left 5. And then from there, it looks like that. Okay? So, with that in mind, I want you to try to figure out, what do you think y equals x minus 1 squared plus 3 would be? Where are we going to move? First, write down where you think we're going to move. Okay. This means move right 1, and this means move up 3. Okay, and from there, we're going to do our good old x squared. So right 1, up 3. It's centered there. That's the vertex, not the center, the vertex. So then, if you just go over 1, up 1, over 2, up 4, because 2 squared is 4, 1, 2, 3, 4, there you go. And left over 1, up 1, left over 2, up 4. And it looks like that. Okay? I'm glad you were able to carry on this whole time. I hope you learned a thing or two about graphing basic quadratics. Take care. Toodles.